Welcome to section 8.3, absolute value equations and inequalities. Hopefully by the end of this, you all will be able to solve and graph absolute value equations and inequalities. So let's talk about absolute values just for a minute. Absolute value represents the distance that a number is from 0 on a number line. So the absolute value of 9 would equal 9 because it's 9 away from 0 on the number line. The absolute value of -9 would also be 9 because it's also 9 away from 0 on the number line, even though it's in the other direction. So we're going to do a lot of 9s and kind of think about just conceptually some of these absolute value equations and inequalities. Okay, so for part A, where I have the absolute value of x equals 9, we just talked about this on the last slide, where the absolute value equaling 9, you had two different possibilities, right? We had 9 and we had -9. Those are the two possibilities. So x equals 9 or x equals -9. So on my little number line graph here, I'm just going to have a 9 and a -9 and a point on each. Okay? Those are the possibilities for the absolute value equals 9. All right. What about the absolute value of x is greater than 9? So that means that it's 9 away or more. So if I'm graphing that on the number line, here's 0, here's 9, and here's -9, that means it could be 9 away or 10 away or 11 away or 12 away or even more, right? Because of it just being greater, I'm going to use a parenthesis, not a bracket. And more. The other direction, we'd have -9, and we go to the left because -10 is 10 away. That's even bigger than 9. -11, the absolute value of -11, it would be 11 away. So that's even bigger. So these kind of go away from 0 on the number line. How about if I have greater than or equal to 9? Well, the only difference if I have greater than or equal to is that I would have brackets instead of parentheses because I would include 9. So I would still be going away from 0, but I'll have brackets instead of parentheses. Okay? What if we have the absolute value of x is less than 9? Okay? Well, let's see here. Here's 0 on my number line. There's 9. There's -9. So I'm talking about it could be 9 away or less. 8 away, 7 away, 6 away, 5 away, 4 away, all the way down to 0 away, right? So what we're doing here is anything between -9 and 9 have those smaller distances that are less than 9 away. For E, what if I just change it to less than or equal to 9? Well, the only difference if I change it from less than to less than or equal to is that I'll have brackets instead of parentheses. It's still going to be between -9 and 9, but now I'll have brackets because I'm going to include the 9 in those values. Okay? Now, let's go ahead and solve an equation that involves absolute values. Okay? So when you're solving an absolute value equation, you probably are going to notice, should we get two answers? Yeah, we are going to get two answers, okay? But don't get carried away yet. The first thing you should always do when you're solving these absolute value equations is get the absolute value by itself first, okay? As you can't split it apart like we were doing in example 1 until you have the absolute value by itself. So the first thing I'm going to do in this example is subtract 4 from both sides so that I get the absolute value by itself. Now I've got 3z plus 2, absolute value of that equals, and then 15 minus 4 is 11. Now that I have the absolute value by itself, well, if I had like the absolute value of x equals 11, then x would be 11 or -11, right? Well, even though we have a more complicated inside, it still could equal 11 or -11 to get that absolute value. So we're going to split it apart to two equations. So 3z plus 2 could either equal 11 or 3z plus 2 could equal -11 because the absolute value of -11 is 11. So now that I have that absolute value by itself, I can split it apart. Okay? from here, we're just solving each equation pretty normally. I'll subtract 2 from both sides on this first one. So I get 3z equals 9, and I'll divide both sides by 3. So z equals 3. In the other equation, I'll subtract 2 from both sides. So now I have 3z equals negative 13. And I'll divide both sides by 3 to get that z could be 3, or z could be negative 13 thirds, or if you like mixed numbers, that's negative 4 1/3. Okay, so we get 2 different answers for this one. All right, let's try another one. What if everything's in absolute values, like this one? Well, this one's kind of fun. The good news is that the absolute values are already by themselves, so I don't have to isolate my absolute values yet, which is really nice. Okay? So what I would do is go ahead and split them into 2 equations. I'm going to have one equation that kind of looks like it is right now. It equals the positive version of the 3r plus 5. So 4r minus 1 equals 3r plus 5. And the other option is that our 4r minus 1 equals the opposite of 3r plus 5. So then that would be negative 3r minus 5. Now you don't want to do the opposite of both because that would actually be equivalent to the first equation, and you just get the same answer again and you'd miss out on your second answer. So you want to make one of them negative, and if you really prefer, you could have made the first one negative, but you only choose one, okay, to get that second equation. So from here, we're just going to solve normally. I'll subtract 3r from both sides over here to get r minus 1 equals 5, and then I'll add 1 to both sides so that r equals 6. In the second equation, I would add 3r to both sides to get 7r minus 1 equals negative 5. Then add 1 to both sides, so 7r equals negative 4. And divide both sides by 7, so my other answer is that r would be negative 4/7. Okay? So those are my 2 answers that would make that equation true. Okay, now it's your turn. You all get to try one and show me how much you've learned.